Hello everyone. Today I'm going to be talking about floating point precision. You might have encountered this if you ever tried to code that when you add 0.1 with 0.2, the value is not quite 0.3. Most of the time, in most of the programming languages that I have encountered, the answer is followed by a large number of zeros with a rather strange 4 at the end. The same case is there for Rust. Let me do this in Rust for you guys as well. Uh, I'm going to put the value of 0.1 plus 0.2 in a variable x, and then I will print the value or what it. I will print the value of this variable, and let's see if it is 0.3. Again, we have this strange 4 at the end. So the thing is, why do we encounter this 4 when the result should be 0.1 plus 0.2 should be equal to 3? So why the error in precision? So the thing is, when we convert a decimal number to binary, because computers store data uh, in binary. So when we convert decimal numbers to binary, hopefully my internet is not slow enough. Okay. So when we convert 0.1 into binary, the result is something like this, and you can see that there is a repeating sequence of 1 1 1 0 0 1 1001 1001, and then there is 101. I mean, there is a repeating sequence, and whenever we encounter a repeating sequence, whether it be in decimal, for example, we have a repeating sequence 0.33333. When we encounter a repeating sequence, what we mostly do is uh, we try to truncate it depending upon the amount of precision that we are trying to get. So sometimes we truncate it to 0.34, sometimes we truncate it to 0.334. In physics, in high school physics, we mostly truncate it to 0.34. Uh, and the answers check out because that is the amount of precision that we are going after. But computers are quite precise. So when this value gets converted to binary, they truncate it according to the IEEE 754 standard. I may have butchered the standard. I do not correctly remember what the standard is called, but uh, so if the language follows that standard, they convert these numbers get converted into their binary counterparts, and the value gets truncated. And when you add up these values, uh, you get this result. But if I change this to F32 in Rust, this basically just means it's a floating point integer of 32-bit. Okay. Now, if I run this, you will see the value is actually 0.3. So why is that? This is because the amount of precision in a 32-bit floating point integer is less compared to the default F64 value. So on most modern machines, if you do not have a computer from like 10 or so years ago, you would most probably be running a 64-bit operating system, and hopefully you have a processor that supports 64-bit architecture. So if I change it to a 64-bit uh, floating point integer data type, again I'm going to face this issue. So basically, it all depends upon the amount of precision that we are trying to get. So this was all for this video. I hope you learned something new. And if you are ever confused about this dreaded problem in precision, hopefully uh, I was able to I was able to shine some light on this. Thank you so much for watching this video, and I will see you next.